Alright, folks. It's the last day of a guest speaker. Mrs. Colson is going to work through kinetic energy with you. And then there's going to be a worksheet after that. And then I'll be picking up again next week. So thank you for bearing with the guest speaker. She's been great. She's been doing this longer than I have.
Alright, so what you should have gotten from yesterday is that potential energy is basically stored energy. If something's moving, it can have potential energy, but it's going to be less depending on where the item is or the amount of forces on it and so on. So the first type was gravitational potential energy, and there's two main things that really affected that, and that was the mass of the object as well as its position. So for instance, that picture there, the elephant on the left, we're going to assume that it's the same elephant, but the one on the left is higher up, so he has a greater potential gravitational energy because he's higher up versus the other ones lower to the ground. Chemical potential energy, you have to understand that in substances there are chemical bonds that make up everything, and depending on the chemical bonds and they break down, they can release energy. So for instance, you get energy from the things you eat. So depending on, let's say you ate crackers, 2 saltine crackers versus a whole bowl of spaghetti, which one of those two do you think you're going to have more potential energy inside? It's probably going to be the spaghetti. You're probably, if you're using it as a fuel source, you're probably going to be able to go farther and longer with the other one because it's more of a complex carb, and there's more of it there than in the saltine crackers. Yesterday there was a car example too. Gasoline makes the car move, but there's a chemical reaction that happens to the gasoline, which is then used to help move the car. Now, the elastic potential energy, it's a force that's pushed or pulled, and it really just depends on the mass of the object as well as the distance that it was actually moved down, or the force that's pushed down with. So you could have a diver, they jump down, pushing it down. That bending motion would be the elastic potential energy, and depending on how hard she pushes would be like the force that's pushed or pulled. And then depending on how hard she pushes, it depends on how far the diving board's going to bend, and that's going to go towards that elastic potential energy. So what I want you to get from yesterday is that there's the three that we talked about are these three, and they have the potential, okay, to cause movement. They have the potential, it's stored energy, to turn into something else. Now, some of those things that they can turn into, we're going to talk about today. All right, the big one that they really turn into is a type or form of kinetic energy. And from yesterday, we learned that kinetic energy is the energy of motion, and it increases with speed and the mass of the object. All right, so the big part from yesterday was him throwing the rock, okay? Now, the bigger the rock he threw, the more damage it was going to do to the giant because it would have had a larger mass, and as long as the speed was the same, it would have hurt him more. But the main idea here is that kinetic energy, if anything is moving, it still has kinetic energy. It also technically still has potential energy too, but the definition of kinetic energy is just the motion part of it. It's the energy of motion. Now, remember yesterday we were talking about how as the rock was falling down on the ground, it was losing potential energy because its distance from the ground was decreasing, but its kinetic energy was increasing because it was accelerating faster. And then at some point it hit the ground, and then once it hits the ground, technically there's no height, so there should be zero potential energy anymore, and it's no longer moving, so there'd be zero, but you can't just destroy the energy, so where does it go? Well, it goes into the ground, all right? And multiple things can happen with this. There's different forms it can turn into. It's kind of like it gets split. But you'll notice in the picture, you notice how he put a big hole in the ground when he hit the ground? Well, he did work on the ground. He actually hit the ground with the force and did something to it. This has to do with mechanical energy. So mechanical energy is the sum of kinetic and potential energy that is in it to do work to make it move in the direction of the force. So basically the definition of to do work is basically to move something, if you will, in the direction that you hit it. So the giant was falling, right? And he hit the ground going down. And did he do work on the ground? Well, he displaced all this ground, so he actually moved the ground, so he did work on it. So what happened is he put mechanical energy was done to the ground. That 50 joules of kinetic energy and that 50 joules of potential energies, they would add up together to do work on the ground, and that's where that went. All right, he made part of the ground move. He did work to it. I know this is a little confusing. That's okay. Just bear with me, and I'll zoom with you if you need it. We can do more examples. But I have another example on the ground. So you've got a house, and you got a wrecking ball. Now this wrecking ball has potential energy because it's up high, and as it swings, it's moving. It has kinetic energy. When it hits the house, if you add whatever the kinetic energy is and the potential energy, you're going to get mechanical energy. So it did work on the house. You notice how it made it move? The house has moved. There's cracks in it. It's been displaced. Pow! Well, that kinetic and potential energy turned into mechanical energy. Think of mechanical, things that are mechanical would be like a bike and it moves. So if work has been done, something has been moved, it's basically just taking the PE and the KE, the kinetic and potential energy, and adding them together. So what I'm trying to say is that potential energy and that kinetic energy, it didn't get destroyed. It got turned into mechanical energy by moving the ground, by damaging the ground for the giant and for damaging the building at the wrecking ball scenario. Here are some more examples of mechanical energy. So remember we did the energy sources, and some people had hydropower? Well, they used the potential energy of the water. So they built the dams and they let the water fall down, right? So this water has potential energy because it's up high. And as it falls, it's gaining kinetic energy, right? But once it hits this wheel, it's doing work on the wheel. It's making it move. It's making it have mechanical energy, okay? Now, if I wanted to know what the mechanical energy is, we would just figure out what was the potential energy and what was the kinetic energy. We'd add them together, and that would be mechanical energy. So in this scenario, you could say that the potential energy of the water was turning into kinetic energy, and when it hit the wheel, they added together and it turned into mechanical energy to make the wheel move. Same thing happens with the bow. Okay, he's applying elastic potential energy to the bow, right? And when he's even having kinetic energy because he's moving while doing so, but he's going to slow down because it's getting harder to pull back. Well, when he releases it, they're going to take whatever the kinetic energy was and the potential energy, add them together, and what you get is going to be mechanical energy of what this arrow is going to take to fly because it's going to move. Same thing with the hammer. Okay, he's picking up the hammer, right? So he's got potential energy, gravitational. He slams it down. Some of it's being turned into kinetic energy. If I asked you what energy hit the nail, what mechanical energy, because you're going to notice the nail moved, it's no longer in the same spot, you would take these two and you add them together. So potential energy and kinetic energy can turn into mechanical energy as long as it's moving something, as long as it's doing work to that item. So kinetic energy has many forms. Okay, when the hammer hits the nail, yes, it turns into mechanical energy, but you know what? Do you think that maybe you could hear it? If someone's banging, doing construction at 8 a.m. in the morning, can you hear them whack, whack, whacking on the top of their house? Yeah. People don't like it when you work on your house or mow your lawn early in the morning because they can hear it, right? So another type of kinetic energy that could be that potential energy can be transformed into, and as even mechanical energy, would be sound. Now, sound is energy that moves through substances as vibrations. Sound requires a medium to move, This means it needs matter to move like solid, liquid, or gas. Remember how we talked about how Star Wars is not realistic because you don't hear the pew, 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 pew? It's because there's no gas. There's no gas in space. So those pew, 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 it would never reach your ear because there's nothing for the sound vibrations to travel through. It needs something to bump into to travel through. Now, the movement of the particles the sound uses to travel through is how it actually travels in itself, and it's kind of showed below. So these little polka dots down here, okay, those are all air particles. And when that mallet hits that side, it's bashing them in together, and then it causes a domino chain effect, and it's causing the sound to travel. So this initial cluster, it's going to bump, 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 and you can kind of see it here, so it's traveling in this direction. And eventually it slows down because every time it hits a gas particle, it's going to lose some energy. But that's one way that sound can travel. And since it's moving, notice how it's movement? Because it's energy and it's moving, it's a form of kinetic energy. You can see those same air particles right here, those clusters, as it goes chirp, 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 and over time it's traveling until eventually it gets to your ear and you can hear a bird. Same thing with her voice. When she sings, la, 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 it's traveling, and you notice how that sometimes it can break glass? Well, glass actually has the ability to move if the sound is at a certain frequency, and if you hit it right, you can shatter the glass. So sound is energy, and it's moving. Therefore, it's a form of kinetic energy. Down here, we've got a plane that is breaking the sound barrier, meaning that plane is moving faster than the speed of sound. Notice how I said the speed of sound? It means it's moving. Especially you boys, you might recognize this one down here, a flashbang. If you ever played Call of Duty or any of those games, it's kind of like a grenade, but what it does is it lets out a really loud noise and a really bright light, so it kind of confuses your enemy. Well, that big bang sound, it hurts your ears and it's going to start ringing, okay? Energy traveled through the air into your ear, and that there's so much energy behind it, it hurts your ear. So sound is a type of kinetic energy because it's energy and it's moving. Now, sound is a vibration, so it would make sense that just vibrations by themselves would also be a type of kinetic energy, and it's actually called vibrational kinetic energy. Once again, it's energy that's moving. That's the key. It's moving. So one example would be like earthquakes. All right, we talked about earthquakes earlier in the year. They're moving, they have a lot of energy, and there's so much that they can even cause buildings to fall. The lawnmower, if you've ever ridden on a lawnmower or pushed it, now when you're done, you'll notice your hands are all tingly. It's because the vibrations from the engine travel up the metal, that's the solid medium, and into your hand. So you're actually feeling some of the energy being lost, and it's going inside of you. Those of you who play baseball, and you know how I feel with this, you know where I'm going with the baseball part. When you hit the ball, sometimes the vibrations from the ball hitting the bat travels down the bat and it hits your hand, and the vibrations go there and it hurts. My band people who play band, when they hit the drum, not only does it make sound that travels, but the whole drum itself starts to vibrate and it makes a noise, and the way you stop it is you put your hand there and those vibrations go into you and you absorb the vibrations. So it's basically it stops. So vibration is another type of kinetic energy because it's energy that is, keyword, moving. Right, thermal energy is another type of kinetic energy, which means there has to be some sort of movement here. Now, heat energy is produced when a temperature increases, so something's getting hotter, right? And when things get hot, it causes atoms and molecules to move. There you go, there's the key part. Move and collide with one another. So if we look in this pot of water, you're going to notice there's a bunch of water particles. Now, when the heat hits it, it actually kind of excites those little particles and they start to move. And as they start moving, they start bumping into each other and colliding and transferring the heat. So as the heat's making the water move, and since it's moving and it's energy being moved, that is the form of kinetic energy. That's called convection, by the way. Conduction, you'll notice here, when you touch the handle, it gets hot. Well, the particles inside the metal pot, they get excited too, and they bump into each other. And they bump into each other, and to the point where it transfers that heat, and it goes all the way up there. So that heat energy here is being moved from here up the handle. So that's a form of kinetic energy, since it's energy being moved. Same thing can be said if you put your hands out there in radiation, you have gas particles. When the heat heats up the gas particles, they also get excited and they bump into each other and they start moving faster. Same thing goes with hot air balloons. That's what helps them fly. Those of you who play Assassin's Creed, you might know where I'm going with this. This glider, it needs something to push up. Okay? If it flies over the fire, those gas particles are excited and they're moving around and they're bumping and they push up. And that pushes up on the glider to help them fly. Alright, the last type of kinetic energy that we're going to talk is electrical energy. Now, this is energy that results from the flow of electric energy, and if it's a flow, it means it's moving. So you have a type of energy moving, therefore it's a type of kinetic. So you have electrons, and you'll notice that they're all moving around in a current. That's the kinetic energy. If you had a light switch, the second you turn it on, you're allowing this flow to move, and that's why your lights turn on. The second you turn the light off, though, you cut it and you stop